Alright, so hydrogen has H2 and it has a mass of 2.016. Ammonia is NH3, which is 17.024. Steam, of course, is water. That's 18.016. Helium, right, that's 4.008. Of course, I'm getting all these from the periodic table we learned in the last unit. Sulfur dioxide is 1 sulfur at 32.07, and 2 oxygens are 32. That makes that 64.07. Alright, so we want them to go from the highest rate to the lowest rate. So if I want the highest rate, I need the smallest molar mass. And so that's going to be hydrogen, and then helium, and then ammonia, and then water. And then finally the slowest, right, is sulfur dioxide. So from the fastest rate to the lowest rate, right? This one's fastest, this one is slowest, right? Alright, so now we can actually calculate the rates, and we do that by doing the square root of the molar masses is equal to their rates. Now, because they're inversely proportional, right, their molar masses and their rates are as well. Okay, so that would be our formula. Now, this formula is not in your reference packet. Okay? Alright, so we want to calculate the rate of diffusion with helium and nitrogen. So first we need to know their molar masses. So the molar mass of helium is 4.008, and the molar mass of nitrogen, which is diatomic, is 28.02, right? Grams per mole. Grams per mole. Alright, so now let's use the equation. I suggest putting your bigger molar mass on top. That makes your math easier. So we'll put our bigger molar mass on top, which is 28.02. And we're going to divide that by the smaller one, 4.008. And that's equal to, notice the rates are opposite, right? So that's equal to the rate of helium compared to the rate of nitrogen. Okay, again, they're opposite each other, right? Your A's are opposite, your B's are opposite. Alright, so now let's calculate that. So we take the square root of 28.02 divided by 4. If you have an older calculator, you need to put that in parentheses, or you can divide and then take the square root. And so that tells us that we get 2.65. Now, what does that mean? That means that the rate of helium is 2.65 for every 1 nitrogen rate. Okay? So rates are generally in terms of a speed, right? And sometimes there will be milliliters per minute, or they could be, generally their volume per minute. It could be a number of particles per minute, depending on how they're measuring the speed of the gas. Right, so what this says is that helium is 2.65 times faster than nitrogen. And so that's how we would write the answer. Right, so helium is 2.65 times faster than nitrogen. Or you can write that helium diffuses, right, 2.65 times faster than nitrogen. I actually just noticed that we were talking about effusion, so we really should change this to effuses 2.65 times. It doesn't really matter, except for that's what the question was asking. The math is the same, whether you're talking about effusion or diffusion. Alright, and so that's Graham's law and Dalton's law.